guys, Chad here. I'm just going to do a quick Bayes theorem problem. We're going to focus on this problem just to help you see what to expect when you read like a paragraph. Go ahead and stop the video and practice this problem on your own, and then when you're finished, see if we come up with the same answers. So you read the problem. You work in a supermarket and you know the technician who works on the registers does a good job at fixing the equipment. The probability that a random register chosen to be correctly set up is 80%. When change is distributed automatically, the probability that it disperses the right change amount if the machine is set up correctly, or if the machine is correctly set up, is 80%. If the machine is set up incorrectly, there's a 40% chance that it gave the right amount. Find the probability that the machine was set up correctly given that the change was rightly distributed. So first off, I gave you some annotations to help you. You have probability of C, IC, and RC. Well, the first thing is that we need to know is, what is the problem asking? Find the probability that the machine was set up correctly given that the change was rightly distributed. So the word given shows you that it's a conditional statement. So we say the probability that the machine was set up correctly, so correctly set up, given right change. And that's what the question is asking. The formula for that is correct and right change divided by right change. You read in the problem, what are the information that they gave us to us? They said the probability of correct is 0.80. So let me search this. The probability of correct is 0.80. So the probability of incorrect, which is the opposite of that, or complement, is 0.20. They also go on to tell you that the probability when change is distributed automatically, the probability that it dispenses the right change amount if the machine is set up correctly is 80%. So what they gave you is right change given set up correctly is 0.80. They also give you right change given the machine is set up incorrectly is 0.40. You need to find out what information can I find out with this. Well, pause the video again and try and see what you can figure out. Okay, so what they gave you is the probability of R and C. Because R and C is R, my mistake, RC and C. Because RC given C multiplied by C will give you that answer. Well, we have those numbers. Those numbers are RC given C, back from the information, is 0.80, multiplied by correct is 0.80. That should give you 0.64. Then we need to go down and find RC and IC, which is RC given IC multiplied by IC. Once again, we have those information. RC given IC and IC, which will give you 0.08. Now, you need to realize, what do these both have in common? Well, these both share RC. They both have the right change. Whether it's right change and correctly set up or right change and incorrectly set up, they both share right change. So RC is equal to 0.72. Well, the right change is 0.72, so wrong change is going to be the inverse of 0.28. Now, what comes on is that you go back and you read what the problem asked. The problem said, hey guys, what is C given RC? Well, we found out the information that we needed, and it's going to be C and RC, which is also the same as RC and C, which equals to 0.64 divided by 0.72. And your answer will be something along the lines of 0.8889 or 0.888 repeating. Now, people are going to wonder, why did you add these two to get RC? Well, you come down here and then have a joint probability table. Now, remember, from the problem, we know that C is 0.80. So IC must be 0.20, right? We went on and we said C and RC is 0.64. Right? We also went on and said RC and IC is 0.08. Well, you add these two and you get this 0.72. And that is why you get 0.28 for wrong change and 0.72 for RC. Just like how you add them here, you add them normally just like that. Because if you look in both cases, RC and IC both share RC. So your answer would be 0.8889. Now, I went through that pretty quickly, but you can always pause the video and go back and try and stop, and see where you can get what you need. So once again, it is this problem. I made this problem up when I was in class, sat down, spent about 10 minutes putting it together, adjusting it, and this is a good problem to understand how Bayes' theorem works. It makes you have to think outside the box. It makes you have to find additional probabilities to get what you're looking for. Yes, you could go ahead and finish setting up the rest of this table to get your answers, but remember, these are joint statements, so they're not given statements. So some people will put RC given C and put 0.80, which is incorrect. You cannot put 0.80 in that column or in that cell box. And this is a really good problem to understand Bayes' theorem. So go ahead, try it until you master it, and then you can start to understand how this works. All right? Take it easy, guys.